Part number 3, graphs and stats. So again, start early. These take so much time. People underestimate how much time good graphs and good and illustrations and even your statistics take. So yeah, don't underestimate it. Start as early as possible. When you have your results, even your first results, go put them in a graph, go put them in a table. These have to be clear and catchy. We'll dive a bit deeper in that. You can use things such as Biorender. Amazing. There's a free version and a paid version. I use this to make all my illustrations. I'll show you some of my illustrations, and it is amazing. It's an amazing resource. It's like a drag and drop thing, and you can like pick different kind of elements and do stuff. It's pretty cool, especially for science. This is like for science associated research. Then you got Prism and Excel. This is for doing your statistics, etc. Prism is this thing here. I think that it's only paid, but our university, UCL, gives this for free for the year that you're doing dissertation. And then also Excel to do your statistics. And then this is another thing for the science people out there who are looking at cells. Fiji, or aka ImageJ, very good program. I'll show you an example, and there's lots of plugins for this, such as AI plugins, etc., which recognizes cells. It calculates by itself like roundness and how big they are, and volume, and the diameter, and how many they are, and their morphology, so you don't sit there doing them yourself. So this is an example of a figure. So what is a figure? A figure is basically this thing here. A figure can have in it some images, and it can be divided in other smaller graphs or illustrations. So here, this figure has 2 elements to it, A and B, and you can see them here, A and B. And again, these are made on Biorender. Like all the elements, etc., I have to drag and drop them, etc., and I just basically show the corneal transplantation procedure. And then you have your legend. This is important as well. Always have legends. And what I do is I write my figure 2 dot corneal transplantation. This is the name of the figure. And then I go part A, which is this part here on the left. It's like, this is the full thickness corneal transplantation procedure, and then I talk about part B, etc., and I just talk about what's going on. You can use figures. The good thing about figures is that you can use them in order to say stuff without actually saying it. So let's say you've gone over your word limit, then you can use figures in order to save on that word limit. Very important, and it saved my ass. This is another thing. Okay, this is pretty cool as well. You can use blow up things. So these blow up, I don't know what they're called. Anyway, these blow up squares, they basically go with the same mentality that we talked about, the hypothesis and aims. I think it was in that. No, I think it's, no, in the intro. In the intro, we talked about the funnel shaped method, that you start broad and then you go specific. It's the same thing here. So you start broad, so you got the eye, and then you go specific. You're basically showing them where this thing is. Again, pretty important to help people visualize. So moving on, cut the clutter. Example. So we have our charts here, our bar charts here, and then you don't want the left one. You want a bar chart like your right one. You want to remove the lines. You want to make the labels clear and the axis clear, and then you also want the titles on the axis. This is an example from my dissertation. Some bar charts, and then the other thing to talk about is color. So there's people out in the world that are colorblind, and you don't know, maybe your examiner is colorblind. So you want to use colors that are compatible with colorblind people so that they can actually tell the difference. And you can put a link in the description again for that, so you can find some colors. These are some colors that I used, which colorblind people can differentiate. Other people just use grayscale, like the first example. I think that's a bit boring, so I put some color in it. Significance and error bars, important. So the error bars here, don't forget those, and then your significance. So these stars that you see here just show the p-value, what the p-value is. It could be 1 star, 2 star, 3 star, or NS, non-significant. The 1 star, 2 star, 3 star just mean p-value less than 0.5 or less than 0.005, 001, etc. But what you need to keep, you don't have to remember the numbers, but what you have to keep in mind is whatever you put, say you put 1 star or NS, you have to explain that in the legend. You have to say what that means. That's the important part to keep in mind. So same example as before, include arrows. So you want to say something about your graph. Why don't put an arrow there? You want to say something in the legend. Put a red arrow there, like here. This is the yield point, and say it so the person who's going to be reading it, when he goes back to the graph, he's not looking to find the needle in the haystack. He knows exactly what you mean, and this is especially helpful when you have cell pictures, when you're showing stuff in cells and stuff like that. Follow the guidelines. Pretty self-explanatory. So, Fiji image J, going back to the thing that we mentioned in the beginning, there is a plugin called Stardist, which I really like for the cell people out there. For example, this picture here, these are some microparticles. I basically had to measure the diameter of the microparticles, and I didn't want to do it manually because that's going to take like ages. So you put it in Fiji image J, and it identifies with machine learning objects and then measures them and can give you loads of different statistics, which is amazing. So yeah, go use it. Link in the description for the videos, how to show, etc. Scale bars. Whenever you put a picture, include a scale bar, SOS. Please don't forget it. Like, you need a scale bar whenever you're putting it, so the person who's looking at that picture can know how big or small what you're showing is. And whenever you're putting images which are next to each other, you use the same scale bar. Don't put 1 millimeter scale bar here and then you're comparing it to an image with 100 millimeters scale bar. No, you use the same scale bar. And then you use for kilometers some scale bars here at the bottom that you can see. Illustration. So whenever I'm showing stuff, for example here, I'm showing, for example, how big this particle is and how small this particle is. I'm just illustrating it again, just showing the difference that, you know, V1 is much bigger than V2, making some illustrations to make it more understandable. Tables, you can include images in tables, and again, your your scale bars. Yeah, that's about it basically. Pretty nice tables in order to show the progression of what you're doing here. This is one that we used. And that brings us to the end of this section. Thank you so much for watching. If you enjoyed these, please consider subscribing. It makes a big difference. Please comment. This is important. Comment and put feedback in the comments. The reason why I've done the series is because I've actually given these lectures to students in UCL and in third year, and I've gotten back feedback which I was very surprised by, which is very good. Yeah, they enjoyed it. They got a lot of it, and I was like, because I got that feedback, that motivated me to do this and put it outside, etc. So if there's something that you want to know, or if you like this, etc., say it, and then you basically motivate us in order to make more content that's going to be helpful, hopefully, for you guys. If it's not helpful, say it. And give us a like. That helps as well. That's about it. And all the institutions, you could see them. Yeah. Thank you.